Hello everyone. Today we are back with one of the most underrated algorithm in supervised machine learning, which is Nave bias algorithm. So, if you follow this video till end, then you will understand what do you mean by Nave bias and how the Nave bias algorithm work and where it is derived from. And also, you can build the model from scratch and use it to predict the classification models. So, before we start, here are a few details about DataMonk. In DataMonk, we help students to prepare for different type of interview in different field. We also provide study material on SQL, Python, R, statistic, case studies, and machine learning for their references. And if you want to know more about the DataMonk, then you can visit our website www.thedatamonk.com. So let us start with the naive bias. In our previous video, we have taken several algorithms which can be used for classification as well as regression. But in naive bias, it can only be used for classification models. So first of all, why we use naive bias? So imagine if you are working on a classification problem and have generated your set of hypotheses and created features and discussed the importance of the variables, and in short amount of time the stakeholders want to see the first cut of the model. So what will you do? You have hundreds of thousands of data points and quite a few variables in your training dataset. So in such situation, if I were in your place, then I would have used naive bias, which can be extremely fast relative to the other classification algorithms. It works on a Bayes theorem of probability to predict the class of the unknown dataset. So now we'll see what do you mean by naive Bayes algorithm. It is the classification technique based on Bayes theorem as we have discussed earlier. In this, we take assumption that our variables are not dependent with each other. In simple terms, we say that our naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. Let us take an example. A fruit may be considered to be an apple if it is red and about 3 inches in diameter. So, even if this feature depend on each other or upon the existence of the other feature, all of these property independently contribute to the probability that the fruit is an apple, and that is why this is known as naive. Naive Bayes model is easy to build and particularly useful for a very large dataset. Along the simplicity, naive Bayes is known to outperform even highly sophisticated classification methods. So now we will see what do you mean by Bayes theorem. So this is the formula for the Bayes theorem. In this, we can find the probability of A happening given that B has already occurred. Here, B is the evidence and A is the hypothesis. The assumption made here is that the predictor and feature are independent to each other. That is, presence of one particular feature does not affect the other. Hence, it is called the naive. So let us take an example to get better intuition. Consider that we have a problem of playing golf and the data set is represented as below. So this is our data set for playing golf. In this, we have to predict the play golf whether we can play the golf on a particular day or not with respect to this feature: outlook, temperature, humidity, and windy. If we take a first row of the dataset, means this one, so we can observe that it is not suitable to play golf if the outlook is rainy, the temperature is hot, humidity is high, and the windy is false. But we can make two assumptions here. One as stated above, we consider that this predictor are independent to each other as we already do in the Bayes theorem. That is, if the temperature is hot, then it does not necessarily mean that humidity will be high. Another assumption made here is that all the predictor have an equal effect on the outcome, like 25% for this, 25% for this, 25% for this, and 25% for this. So all feature have equal participation in predicting whether we can play the golf on a particular day or not. So let us look into the formula for this. How can we put this equation into the formula? So this will be our formula. In this, our y will be whether we can play the golf or not on that particular day. And x will be our feature, means that we have to predict the y given that x has already occurred. So from this formula, in the first equation, p x by y, that means that we have to predict whether it is x or not when y is occurred, means that we will play the golf or not is given, and we have to predict that if it is cool normal, true, false, and all that. And then we have to multiply it by py, means that we will play the golf or not, like 1 or 0. And for p and x, it will be same, whether it can occur or not. Here, the variable x represent the parameters of the feature, means the column. So we can simply write into this formula like p bracket y by x1, x2, x3 till xn, and it will give us that p x1 by y, p x2 by y, and so on till p xn by y, and lastly we have to multiply by py. And in denominator, it will be the probability of x1, x2, x3 till xn. So from this formula, we can easily predict whether we can play the golf or not on a particular day with respect to our feature which are independent to each other. As you can see, we are calculating the probability for each case individually. So till now, you should be familiar with how the naive Bayes algorithm work. So let us see what are the type of naive Bayes classifiers. So there are three type of naive Bayes classifier, which are multinomial naive Bayes, Bernoulli naive Bayes, and Gaussian naive Bayes. The most used naive Bayes are multinomial naive Bayes and Gaussian naive Bayes. So as the name suggests, for multinomial naive Bayes, it is used when we have more than two classes and we have to predict whether like 0, 1, 2, 3, 4, 5 values. So in this case, we will use multinomial naive Bayes. This is mostly used for document classification problem, whether a document belongs to the category of sports, politics, technology, and etc. The feature and predictor used by this classifier are the frequency of the words represent in the document. So our next type of naive Bayes classifier is Bernoulli naive Bayes. So this is similar to the multinomial naive Bayes, but the predictor are in Boolean values. The parameters that we use to predict the class variable takes up only values yes or no. For example, if a word occur in the text or not, so it will take the value yes or no. Then after that, we have a last type of naive Bayes classifier, which is Gaussian naive Bayes. In this, when the predictor take up a continuous values and are not discrete, so we assume that these values are sampled from the Gaussian distribution. So after seeing the type of naive Bayes classifier, we will look into some pros and cons for the naive Bayes. So first of all, we will look into the pros. So as we have already discussed that it is easy and fastest classifier to predict whether the class of the dataset belong to 0 or 1 or any classes. It also performs well in multi-class predictions. Our second benefit for naive Bayes is that when assumption of independence hold, a naive Bayes classifier perform better compared to the other model like logistic regression, and you need less training data. Our last benefit for naive Bayes is that it performed very well in categorical input variable compared to the numeric variables. For numeric variable, a normal distribution is assumed a bell curve, which is a strong assumption. So after seeing the benefits of naive Bayes, let us look some cons for the naive Bayes. So the most important con for the naive Bayes is that in naive Bayes, we take the assumption that our variables are independent to each other. But in real life, it is almost impossible that we can get a set of predictors which are completely independent. Then after that, we have another disadvantage for naive Bayes, that is if categorical variable has a category, like in dataset, which are not observed in the training dataset, then the model will assign zero probability and will unable to make the prediction. This case is also known as zero frequency case. To solve this, we can use the smoothing technique. One of the simplest smoothing technique is called Laplace estimation. So now you should be completely familiar with the naive Bayes, how the naive Bayes work. So now we will build the model from scratch and see the code for the naive Bayes with some EDAs. So our problem statement will be we have to create a predictive model which can tell whether the given person will survive the Titanic crash or not. Our target variable is survival, and our predictors are age, travel class, fare, and etc. So to build any model, first we have to explore our data. So to explore our data, first we have imported two libraries, Panda and Numpy. Then we have read our file using the function read CSV and store our data into the Titanic survivor dataset. Then after that, we have removed the duplicate value, if any, using the drop duplicate function. So as you can see, the shape of our dataset before duplicate values is 891 rows and 12 columns, and after deleting the duplicate value it shows the same row and the same column. So that means we have no duplicate rows in our dataset. Then after that, we have printed the head of our dataset. So as you can see, this is how our data look like. This is our target variable survived column. In this, we have to predict whether the person will survive or not using 0 and 1, where 0 means the person will die and 1 means that person will survive. And these are the columns for our dataset: name, sex, age, patch, ticket, fare, cabin, and embark. So now let us look into shape of our data. From this, we can tell the number of rows in the column in our dataset. So as you can see, we have 891 rows and 12 columns in our dataset. Then after seeing the shape, we have used infer function to see that if our data has missing values in particular column or not. And if there is a missing value, which is 30% of the total rows in our dataset, then we will remove that column permanently. So as you can see in this data, in cabin it is only 204, while our total number of data are 891. So we will remove the column cabin with passenger ID, name and other qualitative columns. So now as you can see, we have removed our passenger ID, name, ticket and cabin, which are either of qualitative type or have missing value around 30% of total rows. So now this is how our dataset look like, which have only survived class, which is our target variable, and our predictors. After that, we have used the describe function to see the statistical distribution of the data, and that's how our statistical column look like. Then after that, we have seen the total distribution of our target variable, and if target variable distribution is too skewed, like only our data has only 0 or only 1, then our predicting model is not possible. But in this case, we have a bell curve distribution which is desirable. It can be positive skew or negative skew, but we can predict our model from this dataset. Then after seeing the distribution of our target variable, we have used an unique function which tell us the unique value for each column. And by this function, we can tell which is continuous variable or which is categorical variable. So as you can see, our age and fare, they can be considered as continuous variable, while our survived, P-class 6, patch and embarked, they can be considered as our categorical variables. After that, we have visualized the distribution of all the categorical predictor variables using the bar plot. So as you can see, they all are our categorical predictors, which are P-class 6 and all that, and this is their distributions. And all values are normally skewed dataset, like this is somewhat positive skewed and this is also positive skewed, this is negative skewed, and this is their desirable bell curve. So they all can be used as predictors in our model. So after that, we have visualized the distribution of all the numerical predictor variable using the histograms. So we have two variables which are continuous, that are age and fare, and this is our age distribution, and this is our fare distribution. And after visualizing the individual variables, we can visualize the relationship between the variables. If our variable is continuous versus continuous, then we can use our scatter plot. If it is categorical versus continuous, then we have two options, bar plot or box plot. But if it is only categorical versus categorical, then we can only use bar plot. And this is our statistical measurement of relationship between variables, and they all are tests which tell us the relationship between the variables. In this dataset, we will use Anova test and chi-square test, as we have to find the relationship between categorical versus continuous and categorical versus categorical. So now we will explore the relationship between categorical versus continuous. So our categorical variable is survived and our continuous variable is fare. So we can use the bar chart for this, but first we group by and keep categorical variable in our x-axis and the continuous variable in our y-axis. And now we will group the data with respect to the survived variable, and this is how our group data look like. In survived, we have only two variables which are 0 or 1. 0 means not survived and 1 means survived, and they are the distribution for each variables. And after grouping the data, we will plot the bar plot between the fare and the survived variable, and this is how our bar plot look like, in which we have survived in our x column and fare in our y column. And we can also use box plot to see the visualization between the survived and fare type. So now we will see the box plot between the fare and the survived class. So in box plot, we can see the outliers. So in our data, we have the outlier which is very separated from the rest of the data. So we can treat it to improve the accuracy of our predictive model. So now we will see how to treat the outlier. For treating the outlier, first we will see how many outliers are there. So from this statement, we will see there are three outliers. So we have two options to treat the outlier. First is to delete the outlier record. And our second option is that we can change the value of the outlier to the normal distribution. We have distribution which is above 500. So we can assign it the fare of 300. After the assigning, our box plot will look like this. Now we have treated the outlier which will give us more good accuracy in our predictive model. Then after treating the outlier and seeing the visualization, we will use statistical measurement for the feature selection. So for categorical and continuous variable, we will use Anova Test. So for performing Anova Test, first we will import the library F1way from the SciPy states. After importing the library, we have to group the categorical data. So in this statement, we have grouped the categorical data. Then we have to perform the Anova test. So for this test, we have performed the ANOVA test for fair and survived, and our p-value for this ANOVA test is 1.84 to the power minus 16, which is very less than 0.05. Therefore, we can conclude that they are correlated to each other. After performing the ANOVA test between categorical and continuous, we will see the relationship between categorical versus categorical in statistical measurement. So to see the relationship between them, we use chi-test. So before we find the statistical relationship between the both variable, we will use the visualization. So we have visualized the sex and the survived class. So first of all, we have used the cross tab to group the data in both the classes, and here it is how it look like. So after that, we have plot the bar plot between both the variables, and this is how our bar plot look like. Like in sex, we have two classes, female and male, and in survived also we have two classes, survived or not survived. After visualizing the relationship between both the categorical versus categorical, we will use statistical measurement between them. So we have written the function for performing the chi-square test of all the categorical variable p class, sex and number, and we got the value which is very low. So we can consider all this variable in our predictive model, and by chance if our value is greater than 0.05, then this means we have to accept the assumption h0, which tells that there is no relation between the given variables. After visualizing and using statistical measurement to find the relationship between all the variables, we will pre-process the data for the machine learning models. So there are 5 steps to pre-process the data before using it in machine learning models. First is to treat the missing value. We treat the missing value using interpolate or replace with median or mode values. Then we have to treat the outliers, which we have done already. After treating the outliers, we have to convert ordinal categorical and nominal categorical to numeric columns. And after that, we can use data transformation if our data values are very large. For data transformation, we can use standardization, normalization, log, or square root of the values. By using this, we can reduce the time by a lot. So in this, first we will treat the missing values, but to treat the missing value, first we have to check how many missing value are there. So in each column, we have a lot missing values which are 177. So to treat the missing value, either we can delete the missing value of the age or treat it with the interpolation. So first of all, we will see how the interpolation works. As you can see in the num column, we have the array of the integer data, and we have used the interpolation method linear, which tell us that we have to take the average of previous data and next data. So in this null value, we will take the average of 5 and 4, which come as 4.5. Then we will fill it by 4.5. Same as in this type, we will take the average of 130 and 10, which will come as 70. So we will fill it by 70. And if we have the character value in this, then we can't take the average. So we will use the forward fill or backward fill for this. So in forward fill, we will fill the data by next data. Like in this, we have null value and next is our female. So we will fill it by female. Or if we use backward fill, then we have to fill it by the male. So now you understand how the interpolation work. So we will treat the missing value in each column. So for age, we have used the method linear in the interpolation. And for categorical variable, we have used the forward fill for the embarked column. Then after treating it, we will check whether each column has zero missing value or not. So as you all can see, every column has zero missing values. So we are done with treating the missing value. Then after treating it, we have to convert the categorical data to numerical data. So to convert the categorical data, first we have to check whether it is ordinal data or nominal data. In ordinal data, we have to replace it by manually. So as you can see, we have replaced the male by 1 and female by 0 in our sex column. So that's how our data look like. Sex equal to 1 means it is male and sex equal to 0 means it is female. Then after converting ordinal variable to numeric variable, we will convert nominal variable to numeric variable. And to convert nominal variable, we use dummy variables. There is a simple function known as getDummy to convert the nominal data. So we have used the getDummy function, and now we have convert our embarked variable to our numeric variable. As you can see that we have created each column of embarked as C, Q and S, and how we have assigned the value in each column. So as you can see in our first row we have embarked equal to S. So after converting it, we should have the embarked C equal to 0, embarked Q equal to 0 and embarked S equal to 1. And same as if we have embarked equal to C, then we should have 1, 0 and 0. So now our data is ready for naive bias. And to create any machine learning model, our first step is to split our data into training and testing simple. So basically, we don't use the full data for creating the model. Some data is randomly selected and kept aside for checking how good the model is. This is known as testing data. And the remaining data, which is used to build the model, is known as our training data. Typically, 70% of the data is used as our training data and 30% is used as our testing data. So after that, we have printed the column of our dataset for our references, as we can directly copy it and put it in our predictors. So after that, we have assigned the value to the target variable and the predictor, where our target variable is survived and our predictor are T class, sex, age, patch, pair, embarked C, embarked Q, and embarked S. Then after assigning the value, we have imported a library train test split to split our data into four parts: extrain, xtest, ytrain, and ytest. And we have splitted our data in the ratio of 75% as our training data and 25% as our testing data, as you can see in the test size 0.25. Then for random set, it is just the number which tell us that we have picked our data for training and testing in the random order. So after splitting our data, we will quickly check our shape of our training and testing dataset. So as you can see for training dataset, we have 668 rows, and for testing dataset, we have 223 rows. We can also change this number by changing the size of the test size. As you can see, we are changing it to 0.3, which means that 70% as our training data and 30% as our testing data. So now, as you can see, our value has been changed to 623 as our training data and 268 as our testing data. So after splitting our data into four sets, extend, xtest, ytrain, and ytest, our data is ready for the naive bias. So we will create a model for the naive bias. So to create a model for the naive bias, first we have to import the library Gaussian NB or multinomial NB or Bernoulli NB, depending on which classification are you doing. So in this case, we are doing the Gaussian naive bias because our data is in the form of 0 and 1. That means we have only two classes. And for multinomial NB, we need more than two classes. So after that, we will create our model Gaussian NB. And as you can see in the naive bias, we do not have any hyperparameters. So that saves us a lot of time. And from this, we can also conclude that it is not a complex algorithm. And if we want to create a multinomial NB, then we can simply create it as like this: CLF equal to multinomial NB. Then our model will be created for multinomial NB. So right now we are creating for Gaussian NB, so we do not want to use this statement. So we will comment it. Then after creating the model Gaussian NB, we will fit our data using the extend and ytrain into our model. So as you can see, we are fitting our data using the clf.fit extend and ytrain into the NB. So now we will predict our data using the xtest and put the value into the prediction. So until now, our model has been created. value has been fitted and we have predicted our predictions. So after that, we will directly see the accuracy on our testing data. So to see the accuracy on our testing data for classification, we use classification report and confusion matrix. So we have printed our classification report and confusion matrix, and you can see it here. So this is our classification report, precision, recall, FN score, and support. And this is our confusion matrix. And for accuracy of our model, we get it from the weighted average of the FN score, which is this. As FN score is the harmonic mean of precision and recall. So what do you mean by precision? So for precision, it means that out of all the positive predicted, what percentage is truly positive? And for recall, it is the out of all the total positive, what percentage are the predictive positive. You can also confuse between the precision and recall, but the main focus should be on in precision we need the percentage of all the true positive, and in recall we need the percentage of only predictive positive. Then for our confusion matrix, what do you mean by this column, this column, and this column, and this column? So for 108, it is our true negative. For 69, it is our true positive. And for 20, it is our false negative. And for 26, it is our false positive. So from this confusion matrix, we can calculate our precision recall, and after that we can calculate our FN score. So now you should understand how do we measure the accuracy in our classification. Then after that, this is our data set. In this is our predicted survival, and this is our actual survival. So that's all for the code for the naive bias. Now you should be able to write the code of the naive bias and should know the algorithm how the naive bias works. So now we will see some application of naive bias in real life. So for the application of naive bias, we can use the naive bias in real-time prediction, as naive bias is eager learning classifier and it is a show fast algorithm. Therefore, we can use it in our real time. It can also use in our multi-class prediction, as we have a multinomial naive Bayes classifier. Then after that, naive Bayes can also be used in text classification, predicting sentimental analysis, as naive Bayes classifier are mostly used in text classification due to better result in multi-class problem and for the independence rule. And another application for naive Bayes is that we can use it in our recommendation system, as Nave Bias Classifier and collaborative filtering build our recommendation system that uses a machine learning and data mining technique to filter unseen information and predict whether a user would like a given resource or not. So after seeing some application of naive Bayes algorithm, we will see the tips to improve the power of the naive Bayes model. As we have seen that it do not have any hyperparameters, so how can we improve the power of the naive Bayes? So we can improve the power of the neighbors directly from the data. So for the first point, if continuous features do not have any normal distribution, then we should use transformation or different method to convert it into our normal distribution. Then for second point, if test dataset has a zero frequency issue, as we have seen this while explaining the naive bias, then we can apply some smoothing techniques like Laplace correction to predict the class of the test dataset. Then for the third point, if the remove correlated feature as the highly correlated feature are voted twice in the model, then it can lead to over-inflating importance. So from this, it can lead to the overfit. So from this, we have to remove some correlated feature as they can lead to the overfitting of the data. So after that, our fourth point is that naive Bayes classifier has limited option for parameter tuning like alpha equal to 1 for smoothing, fit prior true or false to learn, class prior probability or not, and some other options. I would recommend to focus on our pre-processing of data and the feature selection, as it can truly improve the power of the naive Bayes model. Then our last tip to improve the power of the naive Bayes model is that you might think to apply some classifier combination technique like assembling, bagging, and boosting, but this method would not help. Actually, assembling, boosting, bagging won't help since their purpose is to reduce variance. But in naive Bayes, we have no variance to start with, so we cannot reduce any variance. Therefore, we cannot use the technique like assembling, bagging, or boost. So that's all for the tip to improve the power of the naive Bayes. So that's it for the naive Bayes. Thank you for your time. Hope you like the video. For more amazing content and more algorithm type of videos, do like and share the video.